All right, this video is to teach the concepts in Unit 2, Lesson 1. What we'll be looking at today are what it means for two shapes to be congruent or two figures to be congruent, talking about finding angles in figures, as well as segment bisectors and angle bisectors. All right, and we'll talk a lot of vocabulary today and a lot of conventions for how we name things that we're going to use for the rest of the course. So this is some foundational stuff today. Today will be fairly simple in terms of the things we look at, but these will build to larger proofs that we're going to do at the end of the unit. Okay, first thing is just a convention that we need to be aware of. I've probably named some angles so far and just haven't told you this officially, but now we need to know this. So when we make an angle, right, an angle is just two rays. A ray, if you've forgotten, right, starts at a point and goes in one direction forever. And if you draw two rays that are coming from the same point, that forms an angle, right, between them. The place where they join, right, this point here, this is called the vertex of the angle. Okay, so I've drawn a picture here. And when we name angles, we will do that in a few different ways. Sometimes they will just put a number on the angle, and then you'll see them right like this. Okay, this is the symbol for angle. Go figure, it looks like a 45-degree angle, right? So sometimes we will simply say angle 1. If there is no ambiguity as to which angle you are talking about, sometimes we will call it simply by its vertex. So this angle, you could call this angle B. That might be confusing though. Let's just say you had a picture like this, right? And so now there's a lot of angles, right? There could be this one, or even, this one connecting these. So when you say angle B, it's not clear which one you mean. So to be very specific, and this is what we're going to do most often, is we use 3 letters. And what we do is we go in order, pick a letter, and then go to the vertex, and then go to the other point. And you can do that in either order. What matters is that the vertex is in the center. Okay, so this particular angle could be called ABC or CBA. And for instance, let me just put another point over here. Let's just call it, point F. If I wanted to refer to this angle, I could call that either ABF or FBA. It doesn't matter which. The only thing, again, that matters is B is in the middle. Okay, it would be wrong if you put A, let's just say AFB. That would be like if you were finding an angle from here, right, with F as the vertex and then over to B, which is not what we're doing. That will matter, and on a quiz or a test, if you were to label something incorrectly, we would take usually like a half a point or something like that. All right, it's also important to be able to read this notation because a lot of times you'll be told, like, find the measure of angle FBA, and you need to know, okay, they're talking about this one. All right, so that's just some conventions for naming things. Okay, vocabulary for today is what it means for two things to be congruent. Two objects in geometry, and that can be segments, angles, shapes. Okay, any geometric object can be congruent to another, meaning they have the same exact size, shape, and all other features are identical. And probably the easiest way to think of things being congruent is like if you could pick one up and put it on top of the other and they would overlap perfectly. One wouldn't have features that the other one doesn't have. Connecting it back to what we did last unit, would be, if you can translate something or rotate it or reflect it, and eventually you can get it to line up with the other picture, that would mean they are congruent, right? So they don't necessarily have to be oriented the same way. For instance, these line segments, right, are the same length, even though they're not in the same direction, right? They have different slopes, but they are still the same size in that sense. Okay, so the way we say this is this symbol here. Okay, that's an equal sign with a tilde on top, or a squiggle as most students call it. To say A is congruent to B, okay, we would write this symbol. And triangles, right, we use this symbol. So it's just a little triangle. It looks like the letter delta, but in geometry, it's not quite a delta. It's a little bigger. Just on a keyboard, that's usually what I'm going to use. This triangle, right, and we name triangles simply by their 3 points, so x, y, z, and l, m, n. Segments we name, right, by just their endpoints. So segment AB, this could also be segment BA, would be the same thing, and you show that it's a segment by putting a little line over top. If you put the arrows at the end, that's something else. That talks about the line, right, that is going on forever, right? That's different than a segment. And then likewise, CD could also be DC, doesn't matter. Same length, so they are congruent. Okay, when we say that two objects are congruent, we do that in a very careful way where order matters. Okay, so when we write a congruent statement, something like this, it actually matters the way we write the letters because what we're trying to do is pack a lot of information into that statement. What we do is we have all the corresponding parts go with one another. So let me actually draw some triangles here so you can see what I mean. And I'll just draw them with the same orientation here. Okay, so let's say this is triangle ABC, and this is triangle LMN. Okay, not only are the triangles congruent, but what we are doing by writing it this way is the letters in the same position correspond to one another. So point A corresponds to point L, meaning they are the same, and those angles therefore are the same. Also things like side lengths. Okay, so BC and MN. Okay, so let's go to our picture. BC, right, is right here, and MN is right here, and you can see, oh yeah, those are the same thing. I didn't draw it perfectly, but let's just assume they are. Okay, so down here I've written all the different congruences that you're being told by this congruent statement. So the order matters. You want to match up the corresponding points of the triangles. That's going to be important, again, when we start doing proofs and things like that, because it'll be important to know which segments are going with one another, especially when the picture is a little ambiguous and it's not sure which is which. Okay, so if we were going to do this picture, right, A, B, C, and D, E, F are congruent, we would ask you sometimes to mark the figure. And the way you do that for segments is you put a little line segment on it. So AB goes with DE. And it's easy to, kind of eyeball this one and see it. But not occasionally, right, it's not going to be clear which segment is necessarily going, so we need that congruent statement sometimes. AB, okay, I'm going to put a little line on it, goes with DE. And when you see these markings, that tells you those pieces are congruent. You'll get used to seeing this. We're going to see it for the rest of the semester. All right, so then what else goes with each other? All right, BC goes with EF. So BC, now I want to mark it a little differently, right? I don't want to put a single line because that would mean these are the same. Not necessarily, so we'll use two lines. And that goes with EF. Okay, so the double lines go together. And then the remaining side, right? You can also wrap around the statement. So AC and DF, AC and DF. Can we just use 3 lines? And you could keep going. You could use 4 lines, 5 lines, as many as you need to differentiate. In other words, you want to say like these are congruent, but they're not congruent to anything else. For angles, you can do something similar. Okay, angle A goes with angle D. So we put a little arc on it. Same thing, angle B goes with angle E. Now it looks like a right angle, but let's not trust our eyes. Let's not assume it's a right angle. Okay, so we just put double arcs there, and then triple arcs for C. And it doesn't matter which one you make single and double and triple, just as long as they're all different. When we ask you to mark the congruences, this is what you would do. And when you're doing proofs later, it's going to help you keep track of what is congruent as you go through the figure. You'll see what I mean when we get there. All right, so that's congruence. And that's getting some vocabulary out of the way. For the rest of the lesson, we're going to talk about some things that are congruent. Okay, we're going to start building up a toolbox of things that we'll know definitely have to be the same, and that will help us prove larger congruences later. Okay, so one big thing that's going to happen a lot in this course is we're going to see two intersecting lines or line segments. When you do that, you're always going to get four angles, right? 1, 2, 3, 4. So what's special about these angles? Okay, the ones that are next to each other, we say adjacent angles. So for instance, this one and this one, or this one and this one, right? Ones that are next to each other are going to add to 180. And think about why that is, right? A straight line is 180 degrees. And so what's happening is just by cutting that in half, you're just getting two different angles, but the parts have to add back up to the whole thing. So adjacent angles are supplementary. You might want to write that down somewhere. Okay, the ones that are across from each other, you might just kind of see this by looking at it, right? This one and this one are congruent, it turns out. And I can prove that to you, right? If we think, let's just give this a measure. Let's just say it is 120 degrees. Well, we just said, great, these have to add to 180. But then also these have to add to 180, right? These are adjacent. So that's also going to be 120, right? So adjacent have to add to 180. And so we can see now these are the same. And the only possibility left, right, going this way is that this is also 60. And so we can see that these are the same. Okay, we call those vertical angles. Okay, so angles that are directly across from each other, for instance, AED, okay, so I'm using a statement here, and CEB, so see what I mean? It's going to be important to know which angle we're talking about. Those are called vertical angles. And those are two things we're going to use a lot. Actually, it'll come up in this course quite a bit. Oh yes, and one other thing is when you write the little m in front of the angle symbol, it means finding the measure of that angle. So the measure of AEC should be this one, and the measure of AED, we don't know what each individual angle is, but we know that they must add to 180. Okay, so sometimes you'll see questions like these. This would be an easier one. Find the value of x and the measure of each angle in the figure. Well, you've got two lines crossing, and you have angles across from each other. So we know those must be congruent. And when two things are congruent, it means their measures are the same. So we could simply set those equal. Okay, so we know 2x plus 21 must be the same thing as 4x. And now we solve. And of course, that's a easier equation to solve. 21 equals 2x, so x is going to equal 10.5. But now, careful, you're not just solving for x, right? That's not where we stop. We also want to find the measure of each angle, not just the ones that are labeled, but every single angle in the figure. So now I'm going to take that and plug it back in. You could put it anywhere, but probably this would be easiest. So let's do 4 times 10.5, and I get 42. Okay, so this now we know is a 42-degree angle. Well, that means we also know this is a 42-degree angle. And then, right, what about this remaining angle? Well, we know 180 minus 42, right, is going to have to give us the answer. So 138 and 138. Now we're done. Okay, so a lot of students lose points on a quiz or a test, however, because they're so used to like, oh, I found x, I'm done. A lot of times in geometry, we're going to find the variable, but then need to go back and plug it in to find the length of something or the measure of something. Okay, so just be sure you've answered all parts of the question. Okay, here's another example. A little bit harder this time. You may want to try this one yourself. I will tell you that you need a system of equations because there's two variables, right? You remember from algebra, two variables is always going to require two equations. So if you want to try this one, go for it. and I will catch up with you in a moment. I want to pause at this point. All right. So a few different ways you could do this one. Most people like to start with their vertical angles. So right away, I know y is going to be the same thing as 2x. Right, now I need at least one other equation. So, different ways I could do this, but I'm going to take the ones that are in the upper left, the y and the x plus y plus 5, because I know if I add those two angles together, they have to equal 180. Okay, so y plus x plus y plus 5 is adjacent. I'm going to use these two equations. You could have also done x plus y plus 5 plus 2x equals 180, right? That just would have been using the angles on this side. You'll get the same result. It doesn't matter. Okay, but you only need two equations. Right, so if you did use that, just see if you get the same answer as me at the end. I'm just going to clean this one up a bit. So x plus 2y plus 5. And then I'll take away the 5, just to make my life a little bit simpler. I'll start by doing this. All right, and now I see, okay, I can make a substitution. You're responsible for knowing how to solve a system at this point. I don't care how you do it. If you use elimination, that's great. Substitution is great. Even graphing would be fine. But in this case, substitution is pretty straightforward. Okay, we can see we're going to get 5x when we simplify that. And so x will equal, hold on, I don't trust my arithmetic sometimes, 35. There we go. But we're not done, right? First of all, it's a system of equations. So if we found x, we also need to find y. But in this case, we can take advantage of the geometry if we want. We could use the angles in the figure, right? And I'll show you what I mean. We know now, it's red, that x is 35. So that means this is 2 times x, right, is 70. So right away, we know this is 70. Of course, we could have also found that by plugging back into that original equation, would have done the same thing. All right, likewise, you don't have to plug stuff in for x and y. You know, hey, if this is 70, that this must be 110, because they must add to 180, and then of course the one across from it also is 110. And you win. Okay, so y is 70, x is 35, and then you have 70-degree angles and 110-degree angles in the figure. All right, one last concept for today is bisectors. I'll pause it. I forgot I gave you this other example. If you want to try this one as well. Okay, so setting this one up. Go back to white. Again, I'll use my vertical angles first. And you actually don't end up needing a system here, right? Because right away you can see, hey, I'm going to be able to solve for x. So sometimes you'll get lucky and that will happen. We can see this will be x is 38. Okay, when we're all done. And so now, like, I could go fill that in the figure. Let me just use red. Okay, so don't always assume you get a system with two variables. And let's see, that's going to be 76 plus 5, and that's going to be 81. And that's going to be 81. And we know this will be 99, right? 180 minus 81. So we know, therefore, that this must also be 99. Okay, so we can set that equal to solve for y. So we can say so 4y minus 1 equals 99, and that's going to work out nice. Okay, 4y is 100, so y is 25. Next to each other, 180, across from each other, congruent. Last concept for today is what it means to bisect something. Okay, a bisector splits a segment or an angle into two congruent halves, pieces, whatever you want to call them. Okay, for a segment, we're always going to be going through the midpoint, right? So if something is bisecting another segment, that means it is going through the midpoint of that segment. And so we would say CD bisects AB. Notice only AB is being cut in half here, right? A lot of students get this in their heads, like, oh, if one of them's being cut in half, then the other one must be getting cut in half. And that could happen, but you could have a picture like this, where, right, one of them is definitely being cut in half, but not the other one. So the order, again, matters there. The one doing the bisecting is not the one being cut in half, right? CD is bisecting AB. That means AB is the one being cut in half. Same thing for an angle. Of course, an angle is going to be bisected by a segment. Okay, so AY is bisecting XAY, or sorry, XAZ. And so you could say angle XAY is congruent to YAZ, for instance. Okay, so we might give you questions like these. So they're telling you, okay, so they're always going to give you information at the start of a problem. It's important that you read those things. GH bisects FGI. So this figure was already marked for you, but you would want to put in those markings if they're not already there. Like, okay, now I know these angles are the same. And so we want to solve for x. Well, okay, because it's bisected, that means we know they're equal. So we can set these equal to each other. And a lot of times you end up getting very simple equations to solve. It's just a matter of knowing how to do it. And so that'll mean x is 11. But then we also, again, make sure you answer the question. We want to find the measure of FGH. So which angle is that? FGH, okay, that's this one. And so I know this is the measure, so I would simply do 3 times 11 minus 3, which is going to be 30 degrees. Now, I could plug into the other angle, right? They want me to find HGI, but without doing any work, I know it's going to be 30 because I know it's being bisected. But just, if I wanted to double check, I could do, minus 14. And yeah, that's definitely going to be 30, right? 44 minus 14. So this is 30. This is 30. And then the last question, right? What's the measure of FGI? Well, that's the whole thing. And so it's just equal to the sum of its parts. We would say 60 degrees. Okay, so there's nothing terribly difficult about this question, but you need to understand the vocabulary, the symbols, what they mean. And this will lead again to more complicated things. All right, one last question here. So no picture drawn. They're just giving you information. Okay, point B bisects segment CD. Now they don't give you a picture. You should probably draw one, right? Draw CD. And point B is cutting that in half. Now they're giving you some links, right? CB is this, and BD is this. Well, drawing the picture helps you see, okay, so that means the pieces, right, the halves are going to be congruent. So I can set those equal. And solve. And that's going to give me 5x equals 20. X is going to be 4. If you go ahead and do that. But then they want the measure of CD. Okay, so they're looking for this. So plug into both pieces is a good way to check, right? So this will be 4 times 5 plus 3 is going to be 23. And this will be 40 minus 17. That's also going to be 23. Okay, so we know we did it right because the two pieces are the same. But CD is going to be 46. Okay, and there's no feet or inches, so you just put 46 and that's fine. All right, so if you understood everything in this video, you're good to go. If not, send me an email, let me know, I can help you out. If you could try in the Unit 2 module, okay, I made a new module, Unit 2, Lesson 1, if you could try all the questions there, and of course we'll go over them in class on Thursday, since I'm not going to see you this Wednesday. All right, but maybe I'll post an answer key by Wednesday. All right, again, if you need me, let me know. Otherwise, have a great day.